You're listening to Mario.lebrato talking about the benthic surveys on jelly carbon in the baobab oil field, Ivory Coast, West Africa. In this second video, which is over 2 hours, we're going to walk you through the whole survey in detail. We're going to talk about species and the jelly carbon, and we're going in transects. Here you are in transect number 1, so in the shallow shelf. We want to walk you through details, everything that happened, pretty much as we analyze it. So here we are in the surface, starting with the aerobic surveys. Here we are checking some oil rig structures at 15 meters. You can read the lat and long in the screen at the same time as us. You see it north and east, and then the depth reading, and then the date on the left side, and then a couple of other data and numbers for that the aerobic uses. So here you're already seeing pyrosomes at shallow depths in the shelf. Very few though, we didn't see many in the shelf. They started to appear deeper, all the pyrosome depositions. Here we can see part of the pipeline lifted from the seabed, completely covered in mollusks and other crustose organisms. Some isolated pyrosoma in shallow waters, so still at 100 meters. Very few pyrosomes here in the shelf. You can see there are sea urchin, diadema species probably, and also a fish. I can't identify that fish, but some benthic fish. Here you see more diadema, tropical sea urchin with some pyrosomas, which they actually trap with their spine. So we think that part of the pyrosome blooms sunk in shallow water around here, and shallower, and then it was transported deeper and the organisms fed on this like earlier. Because the majority, you will see later, the majority of the jelly biomass is accumulating much deeper. So that's telling us that either it's sinking there or it sunk here first and it was transported downwards. We're now crossing the 160 meter mark, and you see an empty seabed, no animals, no pyrosomes, just the pipeline, excuse me, just the pipeline lying on the seabed, acting as an artificial reef structure, and well, it's also forming channels at times. We will see that later. There comes a fish, cannot really see where it is, but it's hanging there. Some other fish hanging below the pipeline looking for a male. There's another fish in there. We also see some organisms hanging out from the pipe itself. I think a sea spider, we just passed it, a picnic on it, very fast, couldn't see it too much, but yeah, sometimes it's difficult to identify animals in these videos because they go so fast. So here we're crossing the 270 meter mark. We already seen more pyrosomes here in the deep shelf starting to break the slope. Some fish around also below the pipeline. They use it to hide as well. I mean, they just treat it like if they were a rocky shore. But then later on we'll see, like here also, the pipeline just gets buried, and it doesn't provide a shelter that much anymore. You see also in the holes in the sand, some pyrosomes are accumulating. Probably soon we'll start seeing higher densities. So higher densities of pyrosomes and all the jelly carbon sinking occur after the shelf break, just into the shallow slope and then into the deeper slope. We'll see that in a minute. We still see pyrosomes here scattered here and there, not much, not many organisms feeding on them. We're moving now to transect number 2, so 312 meter to near 700 meter. You can see in the map where we are. Here we have an octopus, also it's probably feeding on the pyrosome, so it's trying to look for another meal from some of the other organisms. There's also some crustaceans, identifies Galathea species. They are pretty abundant here and a little bit deeper, and on some occasions they are triggering dominance. We're not sure if they are just comfortable on those depth intervals, or they just taking advantage of the food that they exclude other organisms, but they are pretty abundant on some depth ranges. They are on a kind of you see that one, right? He was taking some food from the look at that another one, taking some food to the mouth with the claws. Some are in, I mean, they're kind of either trying to get some food with their claws, or they just not happy with us. I'm not sure, but they're really looking to get a meal. Well, there are many of them, increasing in density at the moment. Some pyrosomes around hitting them. Some are not happy with their OB, so they probably feeling, they're feeling threatened most likely. We are over 300 meters here, 325 meters. They're pretty big animals. They're very dense down here. We don't see any other animal in these depth ranges. They're amazing. Yeah, we just see all these pyrosomes coming in. It's a shame the ROV camera doesn't show the other side, but that's okay. We can still see what's happening on this side. There you see one walking on the seabed. Not many pyrosomes at this time. What's that? It's a fish. Some sort of benthic fish there hanging out. Some more pyrosomes coming. A bigger pyrosome floating by. Some others rolling. Current is, it's not very fast down here. It gets faster deeper, but here it's really slow. But still, since pyrosomes are not really accumulating here, they move. I mean, they are isolated carcasses, so they can be, taken down easily by the current. They are not neutrally buoyant. They have slight, tendency to go down to the seafloor and stay there. So they can, to transport them by the current, they need quite a strong current. Here we can see there's a lateral current moving them faster and laterally. There's also some crustacean on the left side. Probably as unidentified at this point. It's too far from the camera. A couple of octopus, you can see those guys. They're in the middle of the pyrosomes. They look like they're feeding on them. Too fast to say for sure, but they look like. Why not? Why shouldn't they? Or they may be taking advantage of some crustaceans. Octopus feed on crabs. So this pipeline and the organic matter provides an ecosystem really, because either organisms are scavenging directly on the jelly carbon, or they are predating on each other. So it's really fascinating. You can see here how the current increased and moves laterally the pyrosome. So it's pretty fast, the current here. It's also a fish coming up. Not sure where it is. Some Scorporina species maybe. One of these typical benthic fish, reddish color. Some of the pyrosomes moving laterally and being transported. We already near the 500 meter mark, so we are in the middle of the slope. Here, the slope here is really deep. It's really long, so it's going to take us a while. But you can see the current is really strong here. Pyrosomes being accumulated on the left side and then being transferred to the right side. You can see the process here live. You see how it's being transported laterally and also downwards. Check the depth. We are going shallower in this survey at this point. So, and the pyrosomes are going contrary to us and laterally, so they're getting deeper. We are going deeper in the videos, but in the transects we're going shallower the way the ROV is moving, but just for a few meters. See on the left side some pyrosomes accumulating on holes on the seabed, and now more and more pyrosomes are coming by. Here again, some heavy transfer of pyrosomes from one side to the other of the pipeline. It's fascinating how these things get transported underwater. Fascinating. So ROV stop for a minute here. Not sure what's doing, but we can see that we're not affecting the transport of the pyrosomes. It's not us creating these movements. It's the current. Look at this speed. That's fast. That's fast. That's fast. It's like a benthic storm. That's a disturbance to the seabed. Live. There you go. So we're now crossing the 500 meter mark. We are on 512 meters. Different environment here with less current, not much jelly carbon accumulating anywhere, just some scattered ones probably here and there. We're gonna see what we get. Again, the seabed, the pipeline providing shelter for any organism below it. Some isolated pyrosomes here and there. Let's see where this takes us. It's gone pretty slow, the ROV. It's just checking the ROV here. The task of the ROV was to check the status of the pipelines, to make sure that everything is okay, that there is no holes, nothing is breaking apart, that everything is, in shape. So it's taking a lateral look. You see a fish, then a crustacean, a crab we cannot really identify from the video, and some other small fish around, always hanging in the pockets and in the holes, and always looking for a free meal. Oh, just to remind people, the listeners, to this video, the pipeline we survey had different widths, so don't use it to compare it to animals for the size, or to pyrosomes, because some cases it's 6 inches, others is 12, and I think others is even bigger. So it's not always the same pipeline size. So just bear that in mind if you are making some size comparisons, or you're making yourself an idea of how big things are. Just be careful with the pipe. There we see another crab. Very difficult to identify species from these videos, except when you have a really close up, because ROV is moving, camera is moving, animals are not always in the best position. But well, at least we know what they are in terms of major genus. Current decreasing velocity down here. Still some pyrosomes floating around, but not much action, just some fish as well. We're not seeing many benthic organisms at this point. There we have a very strange fish. You saw it on the left side, like a bubble-like fish. At first we thought we couldn't identify this fish, but then we checked databases, and we think it's Psychroglutus species. I don't know if I pronounce this well. Psychrolutes. Psychroglutus species. Very strange. It looks like a football, really, like a football ball, and then with eyes. A fascinating fish. It's sitting down there at 530 meters depth. Some more scatter pyrosomes around. The pipeline, we can see it here, is partly buried, so it's just not really making any structure. It's just an extra feature on the seabed, just making like a just like making holes and little mountains on the seabed, not making really not trapping anything really. Looks like more like a seabed feature. And then you see again some scattered pyrosomes, very few, but some. They check those holes. The daily carbon is accumulating on them. that prevents the carcasses from moving from the current. I mean, up to extent. The moment the current goes faster than a certain threshold, it will just, move the carcasses. Also some fish using those holes, we just saw it a second ago. Let's see what else comes up. Some more fish still here, benthic fish, 528 meters. Some either actinia, yeah, it looks like an actinia coming from Ctenophora, coming from the seabed. They settle on the sediment and they just grow from there. Yeah, we're crossing now. We're in the 558 meter depth band. The pipeline is totally buried here, pretty much buried. Very few carcasses seen here. Here's a curiosity. You will see later that pyrosome density and the jelly carbon density increases with depth. Not necessarily the contrary, which is what people would normally assume. This is just probably caused by the transport from the canyons and the channels, or that they are sinking farther offshore the blooms from pyrosome, but we don't think so. We think it's just being transported here, because you see very fast transport on the seabed. That was really obvious on some of the images. You've seen it before. We commented how high was the speed, and you will see later also some pulses of benthic current, very strong benthic current. We'll see in a minute. We change now the ROV view. We are in zenithal view from above. And it's a different perspective. It allows to see things from a different angle. We're crossing the 600 meter mark. The first sea urchins are coming here. Those red ones, Hygrosoma species, was identified from 500 meter plus, are very abundant. That was shown in video number 1 in the summary, that they were very abundant. Let's see what we get in this video here. There are a lot of pyrosomes coming here. They're gonna start to be very abundant, those urchins, very soon. Some other crustacean, another crab, big crab, not really easy to identify. There it goes walking, got a little bit scared from us. Oh, what we got here? Another big crab, huge crab on the right side and a small one below. Wow, we couldn't really identify that big crab. It looked like a big spider crab. Another crab here, some Neolithodis maybe, species, genus. Oh, there it is. There is another spider crab there on the right side. Maybe some Neolithodis, Grimaldi. That they told us it could be that species. There it's another one. I really like this depth band. There were quite a few together here. We are in the 600 still here. Some pyrosomes around, increasing at times, decreasing. There is some still benthic fish, more pyrosomes. Oh, here we have some actinia. Actinostola species was there on the left side. We couldn't see it a long time. It came out fast. There's a fish swimming with us, getting scared. (608 meters here, which is getting deeper. It's a bit shallower than here. There was more action. Let's see what we get here. Now we start seeing again some sea urchins, Hygrosoma species. 3 of them here. Some pyrosomas here and there. What's that? Oh, that's just a joint from the pipelines. They're getting, joined together. Nothing major. That comes from construction of the pipeline, the way it was done. Some more sea urchins, hygrosoma, few pyrosomes here. Here we get again hygrosoma and some ophiuroids, Ophiolipedidae. The family most likely, we're not sure about genus or species. Here it's still not a lot of pyrosomes, not a lot of jelly carbon around. Here again more hygrosoma. On the seabed we can see one of them moving. They walk slowly with their feet. So they have the capability of moving really. They can move around to find what they really need. Let's see where else we found around here. More hygrosoma. The seabed is pretty flat at this point. Not much, no holes, no major structures. More ophiuroids there, Ophiolipedidae. More sea urchins. More sea urchins here. Still few pyrosomes around. More sea urchins. Some other fish around, sea urchin again. They are pretty spread out, these sea urchins. I mean, they are very dense at other depths around here, but here they're not. There are not many pyrosomes for them to scavenge or to whatever they're eating. So the sea urchins get more, the hygrosoma get more dense when there are more organic matter, or that's what we see. So here we're not seeing too many of them. I think there is Actinostola there, so the sea anemone, the Actinia anemone there, deep sea anemone. More hygrosoma in the seabed. You can see by the eye, you don't need to work it out. The diversity indexes here are very low. I mean, dominance is high, diversity indexes are low. It's not too difficult to see. I mean, you just need to check the calculations and the graphs that we offer with the results for that. Some more in here, some more hygrosoma. Few pyrosomes as well on the sides. Current is not very strong, otherwise the pyrosomes will be moving much faster. There it's another hygrosoma. That's another ophiuroid. Not really sure about that species. That's more red than the Ophiolipedidae, so difficult to see. Difficult to say where it is. There's another one with the arm tips lifted from the seafloor. More pyrosomes and hygrosoma. By the way, we are now close to the 700-meter mark. We're still under it, but we are reaching there. Here start seeing more pyrosomes. Here there are some accumulations of them. Yeah, you can see all the jelly carbons sitting on the seabed. Sand being clumped together, sand being moved around, transported. Some other hygrosome on the background. Patches of jelly carbon here and there. That's the average. That's the average thing here with the pyrosomes. There are patches here and there, here and there, here and there. That's typical. We know this since the 70s and the 80s in deep sea research that patchiness from food is causing patchiness in organism distribution. It's just normal. It's the normal dynamics on deep sea patterns on food, organic matter, and the ecology. Some organisms in here, fish swim by. We see some more hygrosoma on the background. We change now to a zenithal view from the ROV. We can see things much better. This is the best perspective to really check and identify species. There we have the ophiuroids, big ophiuroids, really big. Some hygrosoma species there too. Current increase here, intensity is much stronger. Pyrosomes moving down. Now we have a right side view perspective of the pipeline. Really good to identify species. Some more hygrosoma here. Jelly carbon trapped under the pipeline and also in the spines of the hygrosoma trapped. An asteroid there as well. More hygrosoma here. Here they start getting dense. Here there are a lot. Here there are a lot of them. Very close to the pipeline. They like it there. Another ophiuroid there in the background. Some pyrosomes around here. More hygrosoma, more ophiuroids, more pyrosomes around. Not very dense though, the pyrosome density here. It's okay, but it's not very dense, just some here or there. But maybe we are missing some from the perspective of the camera. If we were looking to the left side, I'm continuously seeing pyrosoma passing by, so it's also an artifact from the camera. We have to live with it. We're not controlling really these transects. This is done by a DP reel vessel with some operators in the surface from the oil companies checking the pipeline. So we really depend on what they did and the perspective they're using to check the pipelines. Some more hygrosoma in here. They tend to be either isolated or in big patches all together. Some fish move there. Another one disturbing the sediment. Very fine sediment looks here. Looks like clay pretty much, because the moment something moves, it puts up a cloud. So it's not coarse sediment. It's very, very fine, very thin. What's that? Oh, look at that! That's a can. That's human trash at 700 meters. Human trash. That's the impact we can cause on the seabed. There was a ray on the left side, the last move rank. While we were talking about the can, it was a beverage can. That's crazy. I think at some point in this survey we also found a Red Bull can somewhere. That's crazy. Where the impact of human goes. So there you have some more ophiuroids, and I think we also pass again one of these blob round fish, Phrygoglutus at the beginning. Here they start getting more pyrosomes on this left side view from the camera on the ROV. We are on the 723 meter mark. Pyrosomes and hygrosoma, it's the general topic here. Abundant both. Jelly carbon concentrating here on the sides, hygrosoma concentrating heavily on the other side. That's interesting. Wondering what these hygrosoma are feeding, because very few instances we've seen them catching a pyrosome or staying on top of it. So they must be feeding on something else, something associated with the jelly carbon, some sort of detritus, some sort of organism, or they just may be scavenging organic matter remains from the seabed. Who knows, but they seem to love it here. Look how many. Dense, very dense. They're quite big urchins. Very dense aggregation. Here, there's more of them. Some pyrosomes also around. More hygrosoma on the background. You guys realize we've pretty much been seeing hygrosoma for a while. A few species, but this is dominance. You're seeing dominance on the go. Dominance, dominance, dominance. It's not like there are many dominance events, but they last for a very long time. They last for minutes, and even for hours. On the seabed, they last for tens of meters. So this is really interesting. It's really interesting in terms of the amount of seabed they're taking on, and well, it's it's surprising that no other animals like this depth band, or well, it looks difficult to think that it's difficult to think that they are excluding other animals, other organisms, the sea urchins, but for some reason they dominate the landscape at this depth band. You see it clearly. They are predominant species here of hygrosoma. Let's see where this takes us now. It's gonna be for a while, pyrosoma and hygrosoma together, that's for sure. So we now start in transect 3, just deeper. We are really dissecting for you this in very specific detail, so you can check everything in detail. So here you have strong current. You can see what's happening here. Deeper on the 746 depth mark, pyrosomes moving fast, jelly carbon on the move, and a lot of hygrosoma species again causing dominance, or what looks like they're dominating the seabed. And look, pyrosome accumulating. Dense aggregations being transported down slope. Patches and patches. There you have another patch of pyrosoma. Jelly carbon, some rolling on the seabed, literally, others floating near the seabed. Some lifted. There we are. Oh, there is a white sea urchin. This could not be identified, but that's a different one. Wow, look at that density. That's serious jelly carbon. Look, a swimming ophiuroid. Very nice. But look, keep your eyes on the pyrosomes. This is serious stuff. A serious jelly carbon deposition you're witnessing right now. This goes for meters and meters and meters of seabed, and for minutes and minutes and hours. This is serious. You could be watching this for the whole day if we give you the whole videos, because it goes on forever. Where they, well, do you realize that hygrosoma are everywhere now? Literally, they are everywhere. So this was actually one of the motivations for the paper, because it's pretty obvious that there is some dominance. Not sure if it's induced by the urchins, but they're really taking on the seabed here. We just passed one of those unidentified white sea urchins as well. But here the highlight is hygrosoma. It's incredible how many of those are. They're really dense. Really dense aggregations. We also wonder if they are reproductions, or if they're pairing here the hygrosoma, if they are spawning in groups or something. It's just, again, difficult to separate spawning aggregations from feeding aggregations from bathymetric aggregations. It's hard to say, but well, that's what we have. Difficult to check. Another ophiuroid there passes by. This goes on forever. An asteroid there, big one on the background, right side. More pyrosomas, more hygrosoma species. More and more and more, non-stop. Bear in mind, we are cutting the videos for you, so this is just a summary, really. The reality is much bigger, longer. There we pass an Ctenophora, huge one. Oh, aerobase stop. What's that? Looks like some terrestrial debris there sitting on the seafloor. See that? That's the speed that jelly carbon is moving without us moving. It's being transported really fast. Really fast. There you see another swimming ophiuroid. These animals, they don't really need to walk to move from place to place. You've seen it, that they can actually swim ophiuroids. So they are really versatile. Look, another one. They're really versatile. What niches they can exploit. They can move from place to place very fast, either swimming or just jumping in the current. That's amazing. An amazing feature from ophiuroids. Because starfish cannot do that, or sea urchins cannot do that either, or holothurians cannot do that either. They cannot jump in the current and swim. It's just ophiuroids. That's really interesting. Excuse me. Here you see more pyrosomes, more hygrosoma on the background. Again, this goes on forever. We're just focusing here, showing you how the current, how strong it is. It's interesting when the camera lifts up its angle. You see hygrosoma on the background, but we don't really know how far the aggregation goes. I will say it's much denser than this. We're just seeing the tip of the iceberg on this seabed. I'm convinced there's pyrosoma everywhere, and we're just obviously checking this. We're just checking this corner, but they might be everywhere where there's some benthic feature or some channel or some sort of structure or natural whatever. I mean, this is incredible. More dense aggregations of pyrosomes and hygrosoma. I hope it's pretty obvious this is a dominant event. a very big one. You'd only see them, very few other species, one or two other species. And bear in mind that in the paper we just classifying things in 100 square meter intervals. We are classifying things in large bathymetric intervals, so we're not really doing it small scale. If we were doing this, let's say, in 50-meter intervals or 20-meter intervals, there will be dominance in most of them. On, let's say, 500 meters to 800 meters depth, there will be dominance absolutely everywhere. Two, three species maximum we're seeing on these depths with this high proportion of jelly carbon. Another fish scape there. There it is, came back. Benthic fish. Ophiuroid was there as well. More hygrosoma, of course. We're crossing now the 800 meter depth band. Some crustaceans coming on the current. Current slow down here a little bit. We still see some hygrosoma here. Less pyrosoma. Much less accumulation. Later on there is still big aggregations, but well, this is again, as I said before, there is a lot of patchiness happening here. Some more jelly carbon around, hygrosoma, another ophiuroid, these Ophiolipedidae, they're everywhere. One of these that we're not sure if it's Ophiolipedidae or it's another species. Well, that's a huge Ctenophora hanging there in the pipeline. Some more hygrosoma. A crab, looks like a crab on top of the pipeline. Dense aggregations of hygrosoma again, plus 800 meters. Some more fish, some more hygrosoma. Dense aggregation of hygrosoma again. This goes forever. Remember, we've been seeing them at very high densities from 500 meters. This is 300 meter depth interval that we've been seeing hygrosoma at high density, so this is significant stuff. There you can see some pyrosomes. Bear in mind that look what I was to say something, but look at those pyrosomes being trapped. You see on the right side, they have two pyrosomes trapped on the spines, so they're feeding on pyrosomes. We've seen it. We've seen it, you've seen it, it's clear. So I was saying that, well, I forgot what I was saying, sorry. If I remember what I wanted to say, I'll say in a minute. There we have another ophiuroid and more hygrosoma. Where are we changing now? We're still we're shallower. As I told you, the surveys go from, each video changes from deeper to shallower on the same line. Now we're moving deeper again, and we'll go slightly shallower and then we move deeper again. So we just crossed the 818 meter line. Again, we're finding hygrosoma, some pyrosomes around, ophiuroids, the typical deep sea fauna, typical deep sea organisms here. A few pyrosoma around, but we're not seeing the left side, which is important. More ophiuroids, some big pyrosomes there. More pyrosomes. Very big pyrosomes. Look at the size of those. Huge. Very big. Carbon parcels delivered to the seabed directly. Still hygrosoma with pyrosomes. Ophiuroids again. Current again went down here in speed. It just changes all the time. There you have some pyrosomes trapped on the spines. 2 were trapped on the spines. Oh, I remember what I wanted to say before. I was saying that we are seeing aggregations of these sea urchins, the hygrosomes, but what we think it happened is that they might have been feeding on pyrosome corpuses, so the carcasses on the jelly carbon, but then maybe the current got stronger and it moved away the carcasses, and they need to move again to where carcasses are, or they're just waiting for them, or maybe they are fed up. I want to say that we're just seeing really a snapshot of the action, that we don't know what happened the day before and the day after. Maybe they were feeding and the current moved the food away from them, but there's so much food they don't really need to worry about finding it. Here we see asteroid, not really easy to identify. It's even covered in some sediment. More and more sea urchins, never ending the sea urchins here in these surveys. Pyrosomes, looks like a white sea urchin there, surrounded by pyrosomes. He probably traps them with the spines. Well, look at that. That was a hygrosome moved by the current. So if current's strong, it moves everything pretty much. Organisms, pyrosomes, the current moves everything if it's strong enough. More ophiuroids. Well, there you have holothuroid, some Mesothuria species most likely. Yeah, it was identified as Mesothuria. Big sea cucumber, deep sea cucumber. Huge. Still more hygrosoma. We are still at 812 meters. More pyrosoma. It's frustrating not seeing what's happening on the left side of the pipeline, because there could be a lot of pyrosomes in there. More ophiuroids, more hygrosoma. You see, it's the topic for the last hour. We changed depth band now. We are down to 868 meters, so we're getting deeper and deeper on the shelf. We're exploring this deep shelf of Ivory Coast, finding jelly carbon depositions and how they interact with organisms, with benthic organisms and ecological processes. We've seen some pyrosomes being transported from the left to the right side of the pipeline. That's interesting. So we can actually see what's happening. The current is moving the foot down canyon. There you see more pyrosomes on both sides. Asteroid coming up, probably feeding on organic detritus. Another asteroid coming up. A huge actinostola. There are huge actinostola there. They will trap pyrosome carcasses at the minimum opportunity. There is some other actinostola feeding some ophiuroids again. Pyrosoma everywhere. Not very dense in here, just here and there, here and there, here and there. Definitely there are certain areas that are really dense with the carcasses. But others are, well, just average. It's just patchiness. We've mentioned it before. Typical patchiness of the deep sea. It was discovered many years ago. Hygrosoma are starting to disappear slowly. There's less and less and less. So, well, they definitely have a depth band they like. Well, they're probably congregating around the jelly carbon to take advantage of the food source. But, well, they're not here anymore. So, as we said before, looks to us combination of bathymetry and food resource that it's making the aggregations and the dominance events. Here we change to the near 900 meter mark depth. Some ophiuroids moving around. Hygrosoma gone here. This is almost truly deep sea already, so we're gonna see most likely exclusively deep sea organisms. Some asteroid in the background. Some pyrosomes. That red thing, not clear what it is, looks like a shrimp-like crustacean. There you have a feeding event. That's a feeding event for an actinostola. Look, it's engulfing a pyrosoma, you said, and another one from Actinocyphia aurelia. That's a feeding event live. They are trapping the organism and they want to engulf it. Or that looks like. Amazing. Live feeding on jelly carbon. This is as good as it gets. Difficult to get better than this. Quality video and activity from organisms, interactions, well, it has it all. We're really happy that we can show you this survey, so you can really appreciate what deposition event is, how it looks like, how jelly carbon export works, and actually what happens at the seabed with it. Many people wondering. This is what happens. It's a party. Pretty much it's a party. Current slightly increasing and some pyrosome around. Let's see where this gets us. We're gonna find soon some of the deep channels. Here we found some land debris, looks like some wood or mangrove something or tree remains. It's probably transported from the canyons downhill. Another actinostola sitting on the pipeline. Pyrosomes moving down. still in the 900-meter mark. Fish in the background, some shrimp jumping around. Particles moving in the water. Pyrosome carcasses here look very decomposed. Look at that moving. Look at that. That's jelly carbon debris. That's jelly carbon very decomposed. You see it. You're seeing it live. You see it together with fresher jelly carbon, so the carcasses are less decomposed, and you see then all the other debris. Really interesting stuff. And you're seeing it live, how it's being transported. So we're now moving to Transit 4, taking us from 900 to near the 1,000-meter mark. Here you see more pyrosomes, some fish there. Current, it's really strong, or it looks very strong from the screen. The way the speed particles are moving pretty fast. Some ophiuroids on the background. We crossed the 900-meter mark. We are at 904 meters here. Pyrosomes still around. Pyrosomes rolling and being transported from side to side of the pipeline as caused by the current. More actinostola on the pipeline. A huge Actinocephia aurelia coming up. Huge animal here. That's a big one. That's a big one. Arrow beads going backward a little bit. Maybe it's checking if there's damage on that joint. Or bear in mind, we're not driving the ROVs, so they're just doing their work, and we're just taking advantage to study ecological processes. There we go. Looks fine. Now we change the ROV angle.
The ROV continues on a heading of 72.4 degrees at KP 0.7.
Oh, somebody talking on the ROV. There you can see some of the Mesothuria, that big white holothuroid. Very big organism. Quite a lot of jelly carbon accumulating here. Carcasses on the sides. Pretty large ones. Look at that one. The size of those is pretty big. They're not small at all, these pyrosomes. They're really big. They're bulky. More pyrosomes there and there coming down. Some ophiuroids. You can see it by the eye that diversity really went down, and the number of species and the number of organisms is very, the diversity is reduced to very few species here that they can exploit in these depths and these food sources. More pyrosomes accumulated. Some debris that looks some terrestrial debris, tree-like or similar. We keep going, still on the 908 meter mark. Pyrosomes continuously coming. Jelly carbon being transported to deeper depths. We think it's one of the main features here. It's just the carbon is continuously being transported from, shallower depths in the shelf. Shallow slope and then going to the middle slope and deep slope. It's pretty obvious from the videos. If you keep in mind the maps we show you and the transects that you make watching this video, you can make yourself a pretty clear picture of the situation down there and the overall distribution and the extent of the deposition. And well, at this point, if you are a skeptic, you don't really believe the importance of jelly carbon transfer to the seabed, you should really start to believe it, because you've seen a lot in here. You've seen a lot, and this is just one transect. Imagine having a full distribution on the seabed of all these canyons and of all these channels. So pyrosome blooms or any jelly bloom, jellyfish also salps, is huge, can be huge, can occupy many hundred square kilometers. So we're talking about very serious stuff. It's not just 100 or 1,000 carcasses sinking, we're talking of millions. Millions upon millions sinking here. Carcasses keep coming our way, moving down. We're seeing very few organisms at this depth band. Let's see what we find deeper. Most likely there will be more organisms, but this particular area, they don't like it. We're changing now the perspective of the camera and the angle. We're still on the 900 plus, now 958 meters deeper. We're going deeper. Now we're finding more pyrosomes. These are dense aggregations now. Now some hygrosome again. They reappear, they disappear from the previous depth band, and they are back. Dense pyrosome aggregation. Here they come, this hygrosome. There, wow, look at that. That's serious densities there. Very high densities. Still being transported. There you see how pyrosome corpses are moved from side to side of the pipeline. You're seeing it live right now. Dense aggregations of jelly carbon being transported. There you are. Amazing. Deeper, we're deeper now, 975 meters. Still jelly carbon around. More pyrosomes coming our way. Pipeline half buried, not sticking out too much. Some more pyrosomes in there. Patchiness again. We see them clamped together in some areas and more patchy in others. As we discussed before, it's a normal aspect of the deep sea. Here they are again. We are checking now the left hand side of the pipeline, so we're not keeping an eye on the right side, but that's okay. We can make ourselves an idea what's happening. Here the pipeline is really sticking out of the seabed. Here it's where it's appropriate to say, well, this is trapping and it's a more artificial structure, but when it's almost buried, it doesn't really affect anything. We passed San Ctenophora again. More pyrosomes as well. Shrimp like on the pipeline, but impossible to identify. Red, they look red, so and they look like shrimps, so they must be shrimps. Another one of those shrimps, deep sea shrimps. I mean, difficult to say what they are. I think at some point those shrimps were identified because they were very close to the camera. Give me a second, I'm gonna check in the list. We have a list of all the identified species. Maybe that was identified in one of the photos. Let me check 1 second. Don't see it. I'm not seeing it here in the identification list, but I think it was some Parapineus, the species it was. Sounds familiar, that name. I don't have it at hand now, the list, but it was it was a common deep sea species, but we were not really sure from this. I mean, in these latitudes. Yeah, I have it here. I found it. It's Parapineus species. This Parapineus species, this shrimp. Yeah. Or that we identified. I mean, we're not sure if the identification is 100% correct, but from the information we had, it looked to us. There you have another one. They are Parapineus species. Here you have at 986 meters. Pyrosomes in a very degraded state, decomposing. Here we see them all the way. Still some hygrosoma, very few though. You remember the super high densities we had before. Now they're being scattered, very scattered. Some of those shrimps. Look, another feeding event for Nactinus Aurelia. You saw the pyrosome sticking out of its mouth structure, feeding structure. There are more pyrosomes. We're checking now the right side of the pipe. Shrimps, you see them red on top of the pipeline, on the sediment as well sometimes. There it is, one. Scatter hygrosoma, one here, one there, very few compared with before. Now the aerobie, it's going pretty fast. I mean, it's really close to ground and it's moving fast. So we are surveying a lot of seabed now at the moment. There you see more pyrosomes, big ones, degrading, rolling on the seabed. One of those shrimps, Parapineus species, pyrosomes everywhere, absolutely everywhere. Now the pipelines are merging with the seabed much more. We will find a point where they are actually buried. We've been told that they transport the oil and they heat and cool, so that heating and cooling buries the pipeline on the seabed. I'm not sure how, but well, you will see later that it gets buried. So either it's that or it's just a strong current moving sediment. So we're now moving to transect 5, so 1,100 meters and below. So things here getting interesting again. Different depth band, different area of the survey along the slope. So we will find new things. Now the pipeline has a lower profile. It's half buried on the seabed. We see some debris in there. Some pyrosomes, not very high densities, but still. Keep going, and pyrosomes again here and there. The pipeline getting more and more buried. Actinus Aurelia, there we see her on the left side at the moment, close, no tentacles out. She doesn't like what she sees, maybe. Not feeding time. Few pyrosomes now. Just patchiness. They come up in a minute. Ctenophora there. What's that? Oh, look at that. It's a sea pen. I think it was Penatula. Some Penatula species. That's amazing. It's a shame but the camera was not on the left side. We would have seen it much better. So we are on the right side, so we see it far away. But still, that's amazing. A sea pen sticking out of the sediment. Those feed by filtering, so they're not really feeding on pyrosomes, most likely. Few pyrosomes in here. Jelly carbon standing stock and flux decreased a lot at this point. And we're not seeing many animals either. Animals, organisms, they like to be in certain depth bands, but they also like their food. So organisms are always near the food source. Kind of debris on the bottom. I'm not sure what it is all that, but there's debris now. Pyrosomes are there. Some shrimps, a lot of shrimps in here. They're not really shoaling, those shrimps, but they are a lot scattered. I don't know if you guys could see it, but there was one shrimp manipulating the carcasses on the left side just before with its small legs, so we can safely assume it's eating from it or getting some food from it. There you have another Actinocephia aurelia, closed, not in feeding mode. We are at 1,145 meter deep slope. We are in the middle of the deep slope. We are in the key area on continental margins. The slopes are one of the key areas for sinking carbon in the world, really. I mean, shelves are very important, but slopes are by far the key here, because they take all the canyons and they are running from 300, 400 meters down to 3,000 in many cases. So, well, and they are steep, so they are key for transferring carbon in the global carbon cycle. That's very well studied. Pipeline again, getting buried, so just becomes a feature of the seabed on itself, really not acting as a trap or anything. In some cases it's buried with sediment. There you see, you cannot even notice it at some point. And later, as I say, we're going to get the pipeline buried really in channels. That's a big fish. That's a big fish. Not sure if we identified that guy. I don't think so. No, I don't think so. We just put fish number 2. Difficult to identify those animals. Octopus, deep sea octopus. I don't think we identify this guy either. But you see, amazing one. Deep sea octopus. Most likely getting free meals all the time, or predating on organisms that just come to feed on pyrosoma. Octopus love to eat crabs and these things, and well, there are a lot, so they can get a free meal whenever they want. We're now on 1,175 meter, which is going deeper and deeper down to near 1.3 kilometers depth. So more pyrosomes accumulating here. For a long time we have a very weak current, not making major moves, not transferring the jelly carbon as we saw before. Still pyrosomes coming through. Now we're changing the angle of the camera again. We gain deeper again, 10 meters, 1181 meters. You can see now that the pipeline is buried from one of the sides and the other is not, is exposed. So yeah, it's a benthic disturbance somehow. And well, now you can see how the pipeline is trapping the jelly carbon. Very close view, so we cannot really see what's happening in the whole area. But you see some shrimps with these parpenius and some fish still around. It's very narrow, this angle, so it's difficult to see things in it. More pyrosomes being trapped. Another shrimp, one of these white sea urchins you can see with some pyrosomes trapped in the spines. They really do what they can, but the current doesn't really help them. But well, the current brings the food and takes the food, so brings and takes away. So they have to make their best. Here the pipeline is above the seabed, so it's creating some shelter. Not sure what's that. Looks like human garbage of some sort. It's fascinating to find human garbage, and at these depths you can't really see how we impact the world. It's it's amazing the capacity that humans have for disturbance. More pyrosomes rolling by, being trapped on the sides and simply rolling by. There you see more debris and human related debris and trash. Another Actinocephalia, they occur here and there. This one was actually facing down to the seabed, so hoping to get some food. There's a shrimp again, Parpenius. Pyrosomes everywhere, up, down, being continuously transported to deeper depths. So just downslope transport, we can call these processes. Downslope transport of jelly carbon. Another one of those Actinocephalia. That's just a red mark on the pipeline, no animal in there. More shrimps. Another Actinostola with a white sea urchin. We couldn't identify the sea urchin, we just call it white sea urchin. See the current, how it's moving the food, and see the urchin. It has 1, 2, 3, 4 pieces of pyrosomes strapped on their spines, and the current is taking them away from it. But, well, sea urchin is trying it, but, well, that's a piece escaping. You see, it lost it. It lost the food. It had the food, it lost it. So it's a struggle for these sessile animals to get food. I mean, there's so much food on the move, but I mean, they really need to get it. They need to trap it. Otherwise, it gets away from them. It really gets away. So ROB just stopping here. Not sure why. Maybe it's checking something or it's revising something inside. We'll probably resume in a few seconds or in a minute. Now we are deeper. We are near the 1.2 kilometers depth band, so I think around here it's where we get the deep channels on the seabed, that the pipeline really disappears and you see super high densities of pyrosomes being accumulated. Let's see if it's around here. We'll see in a minute. For now, there is no pyrosomes inside here in the field of view. We can see pretty much nothing at the moment. No jelly carbon, no food, no organisms really. It's fascinating. When there's no food, there's nobody around. Let's see. Some actinia on the left lower side, or maybe it was a sea spider. Probably was a sea spider. I couldn't tell really, but I think it was one of these pycnogonids. Sea spider, a pyrosome just cruised by. But there's not much around here now. Let's see deeper. It's nothing, it's just some red whatever on the pipeline, but it's this human. Yeah, they're not they are sea spiders, pycnogonids. You saw it there quickly, pycnogonid. So now we are shallower really. The transect got a little bit shallower, far away from the starting point, but we just went a little bit upslope. Let's see what we find in here. Maybe the channels I'm talking about are here, so we are at 1040 meters really. Upslope a little bit. We came up 200 meters, so that's a lot. That's a distance. So let's see what we find. Some shrimps again back here. Current, it's really strong out of the main channel and the main canyon. This is really open slope. It's not we are in a canyon or in a channel anymore. We are in an open slope, really open to the elements and to anything that can happen. Some pyrosomes still passing by. Few organisms now. Some more pyrosomes start to come up. Some fish escaping on the sides. Some pyrosomes again, jelly carbon carcasses passing by, currents getting stronger. What's that? Jellyfish, look like a swimming jellyfish really, or something like that. Difficult to tell. Some more carcasses passing by. Looks like one of those red sea urchins too. Here the pipeline is getting buried, on at least on one of the sides. You can see sediment on top of the pipeline. It's probably caused from past fast transport from the current. Some extra pyrosomes also on the sides. Some more pyrosomes. We're a little bit far away now from the pipeline on this video, so it's difficult to see the animals. Not many though. There's some pyrosomes there. Oh, that's another Actinostola. There. Some shrimps around, you see them here and there continuously. Some fish erratically swimming around. Not many pyrosomes in this open slope. Potentially this could be that the current is normally pretty strong in this open slope, so that just prevents pyrosomes and jelly carbon from accumulating on the seabed. Most likely it's just being transported elsewhere, and yeah, that's the most reasonable explanation. We move into another chunk of that survey in this area at 1029 meters depth. Seeing more pyrosomes in here. A lot of the debris on the seabed looks coarser, probably moved and excavated by the currents. Some of the shrimps, one of the ophiuroids also here. More and more pyrosomes coming by. Not in dense aggregations though, the pyrosomes, but well, they're still around. Yeah, it means if the current was strong for the few days, like many of the pyrosomes are just being transferred, so these depths with strong current are just transition zones for the jelly carbon, and then they just get accumulated in where there's less current or where there is more conspicuous benthic features that can actually trap them. But the most and single important factor here to move the food, to move the jelly carbon is the current. If it's strong, it's going elsewhere. That's for sure. It doesn't matter there is a pipeline or anything. It will just move the carcasses away if it's strong enough. More carcasses here. Not many animals we see. Here we start seeing these channels I was talking about. We think this is from the heating and cooling of the pipe itself, pipeline that makes these channels, but well, this is really a disturbance to the seabed here. But look, there are pyrosomes, but they're not that many. It's okay. I mean, they could be trapping a lot of them, but they're not here. So the current is moving them somewhere else. And there's some, but not too many. Difficult to see fish here. Too much place to hide. We're still in the channel. We've seen some animals in here, some fish and some shrimp, but difficult because, yeah, it's a not very easy angle. Here we see pyrosomes accumulating. That's an octopus coming up, big one, huge octopus there. That's just a feature from the pipeline, from the construction. Big disturbance here to the seabed, really obvious. Some detritus, looks like terrestrial. Pyrosomes still accumulating on the channels. Actinostola also seen there in one of the channels, and more pyrosomes also on the sides. Fish still around. Few pyrosomes now we're seeing accumulating on these channels, so not necessarily these channels take all the jelly carbon. It just depends on the current and where these channels are positioned, really. I mean, it's a big influence on the current here and the bathymetry. I think we are starting to come close to an area where there is a very high density of carcasses on the channels. hopefully through this video we have some channels where you don't actually see the pipe, and wow, that's full of them, but we have to wait and see. Not sure if it's in here yet. It's quite deep, this channel though. Check it out. It's a big channel on the seabed. Not sure if, again, this was caused by the heating and cooling of the oil inside the pipeline, or if it's just like that, the seabed. Really deep channel there, you see it. Camera from the ROV. It's readjusting the angle. Going quite above now on the seabed. Really high now. We cannot see much of the action now. It's not much action though. I mean, you see that there are not many pyrosomes here or animals, but it will come close. It will come close to the pipeline soon. Not sure what they're checking here. There we are. Now we're coming close. So here the pipeline is literally getting buried. There it disappears. There's no pipeline. It's just sediment. We know it's there, the pipeline, but there's no pipeline to see. There it comes again, the trough, the channels. No jelly carbon in this transect. Pretty empty seabed, no organisms either. There we have some pyrosomes, but not many. You would expect these channels to be really trapping, but they're not. So the current here, as we just say before, it's really important in shaping the patchiness of organic matter and jelly carbon in this continental margin of Ivory Coast. Really important. And we think that the current just shapes it everywhere. So we're now switching to transect number 7. So 1.2 kilometers plus. So we're getting deep in here. And we're going to see some action in here. Current again, it's very strong here. Moves laterally. Some pyrosomes around, not too many yet. Some land debris found. What's that? Not sure. Yeah, probably it's another pyrosome. It's just whiter. Oh no, it's a one of these Mesothuria. That was small size. There you have another of the Actinocyphia Aurelia. Just on the pipeline. There it is, another sea pen. Difficult to see, we don't see many of those. Penatula, most likely, or maybe another deep sea species difficult to identify. There are some pyrosomes, some Actinocyphia, Aurelia. Again, they like these depths once again. There you have another one of these Actinocyphia Aurelia. Some holothurians on the seabed. Mesothuria again, looks like big holothurian. Another of the Actinocyphia Aurelia. Two of them actually. More sea cucumbers. There you see them on the background. And now we're changing again we're changing the area of survey in the same depth. Well, we're still at 1,207 meters. Less jelly carboning here. Very patchy. Some areas have really a lot, others have nothing at all. Just current shaping the jelly carbon and the underwater landscape, that's for sure. Pipeline again above from seabed, creating some potential shelter for organisms, but we're not seeing much action at the moment. There are some sessile organisms on the pipeline, but cannot really tell what they are. We're still in this area, which is pretty barren. Not much action happening here now. Yeah, not much to say here. There is not much action happening. We are hoping to find some good aggregations coming up, but so far nothing. It's just just what you've been seeing. The majority of these last parts of the survey. Not much action on the seabed. Very few carcasses. Consequently, very few organisms. But yeah, well, it's just deep sea, so it's just normal. Some more carcasses in here, some shrimp swimming. Yeah, this transect is getting boring really. It's not much action, that well. We have to go through it. Well, actually, it's data. You know, it's not just the absence of action is also a result. That means something happens here, and we need to report it. So very few food, very few animals. That's what we have. That's what happens. Oh, here you have some. I just wanted to show here some structure on the seabed from the oil extraction. And you see some detritus, some pyrosome detritus on there. So on top of the yellow thing, you see the detritus that settled. Not necessarily has to be pyrosome, but there are some pyrosome detritus at the bottom too that comes up resuspended. Interesting to see is how detritus deposits in these structures in the deep sea, and how how it accumulates. Really, it's like a food hotspot. Although we don't see any animals near this structure, the aerobee is doing something to it. I don't know, cleaning or repairing. You can see on the right side the arm. It's doing some sort of work. You actually see live how the detritus is sinking and settling on this yellow structure. Really nice. So again, now we're going again for survey time. We are again on the seabed, following the pipeline at 1,253 meters. Sam Ctenophora Aurelia coming up. Pipeline here, big one, thick. More Ctenophora Aurelia on the seabed. Pyrosomes starting to be more abundant. Again, so jelly carbon is important again at these depths. It's being transported and trapped on the sides. Huge, what looks like a starfish on the right side. Cannot really identify. Looks like some Solaster species, but it was a little bit too dark to identify. It was a really big one. Pyrosomes here again being transported. Maybe current is increasing here. More jelly carbon trapped, being transferred, being resuspended. We're seeing it live. We're seeing all the processes that we describe in the publications live. So that's where we get the data from. That's where we get our results from, and well, we're pretty confident about what we're showing in the processes. So it's difficult to argue against all this evidence about the importance of jelly carbon deposition for the global carbon cycle and for the biological pump, and especially at a regional scale. Very important. You're seeing more pyrosomes here. Some organisms as well. We're still 15 minutes clear to the end of the video and the surveys, but there's still some action to happen here. Check it out now. Some pyrosomes moving around, and densities are higher. Interesting. You see how pyrosomes are being transferred all the time from depth to depth, and from parts of the seabed to parts of the seabed, and well, that's what it is. We're changing the section here, side view of the camera, also very close-up view on the pyrosomes and the detritus. You can see everything here, still at 1,250 meters, and shrimps pass by. You can see the pyrosomes being resuspended and all the jelly carbon on the seabed decaying. Actinostola on the pipeline, more shrimps. Well, there you are. Human impact on the seabed near an organism. It's some sort of metallic can from a beverage, and the Actinus Cephia really on top of it. Not sure if she was trying to feed on that, but that's human impact on the seabed at 1.2 kilometers. Amazing. Somebody probably threw it from a boat and it ended up in the seabed. Excuse me. So more jelly carbon in here. Another Actinocephia aurelia feeding. Pyrosomes abundant here now. What's that? Artifact. Oh, looks like a plastic bag. Plastic bag. Another human trash on the seabed. That's deep to find this stuff. They're checking the pipeline sideways. Pretty good. We can have a very close-up view of the depositions. Very good stuff. Some debris, looks like land or some plastic, not sure. The pyrosomes trapped, yes, in this case, actively trapped by the pipeline. It's a pretty big one, this one here, so they get really trapped. Another Actinus Cephia aurelia, and now we're changing again the area of the survey, and but still at 1,260 meter depth. So still pyrosomes around. Now decreased a little bit the density compared to before. Some debris, looks like land debris. With still some pyrosomes around. Very few organisms around here now. We're just going deeper and deeper, and the diversity patterns are totally decreasing. It's pretty obvious. You can easily see that from our that there is a big decrease, especially on the transects from the shelf to the deep slope. The mid slope, shallow and mid slope are very few number of species, and then there is an increase, and then they stay constant. But then, for example, the number of organisms per 100 square meters, it's really reduced the moment we go deeper. Species, well, it stays kind of constant a little after 800 meters, but the number of organisms after 800 meters is really reduced, like in terms of organism number. And these might not be really attributed to the jelly carbon. This just might be a feature of the depth. So we're moving to transect 8. We call this various depths. We're not really sure that this was like linear transect. I think they were just checking some sides of the pipelines on other locations different from the linear transect we've been doing. So here you can see a big accumulation of jelly carbon on the sides of this pipeline. Very deep though, nearly 1,280 meters. Very dense pyrosome accumulation here, with a big Ctenophora aurelia in the middle of them. This is interesting. Here they are really accumulating. The current is quite slow and it's not moving them around, so they don't have much to go. They just stay there until the current gets stronger. This is really, really good. They really good images. You can see closely how they are decaying and how densely packed they are. Not much animals though here, organisms, so we've been saying this a number of times, but we think that what we're saying is a dominance on the depth bands that the specific organism is living. So that's important. It's not that there's dominance absolutely everywhere. It's just the dominance is being shaped along the margin by the organic matter, but it's also being shaped by the depth. And it's probably a combination of the two acting in synergy, that pulling one to, I mean, they're both pulling and governing this relationship. There you can see now pyrosomes being transferred from one side to the other, more Ctenophora fitting there. You can see clearly the current, how it's changing even at this depth, how it's moving the jelly carbon around. Very powerful force, the currents, deep sea currents. Here we are, one of the first Solaster big starfish. It has several carcasses trapped under it. It's probably feeding on them. Very big starfish, important member of the deep sea community. Current very strong in here. You see it's actually resuspending sediment, so the debris, you see them being resuspended. Few pyrosomes here now. We are near the 1.3 kilometers depth, and now we are talking on a very dense pyrosome aggregation on the other side of the pipeline, though we don't see it from this side. That we see that they're moving. They're pretty dense over there, and now we're gonna hit some on our side. there's tons of jelly carbon on the right side. We're not seeing it properly because of the camera angle, but we just know it's there because we see them moving. Few animals here though. Another Actinocephia. Maybe we'll see another starfish, some Solaster, but I just want to remind that this is not all the videos we have. This is just a 2 hour and 10 minutes summary. So we are cutting this short. I mean, this is showing you around 10 to 20% of the surveys and everything we've been checking. So you can make yourself an idea of how big this is if we are only showing you 10 to 20%. I mean, this is huge deposition. Goes on forever. There we have more carcasses being transferred. Now you see it very clearly. Well, there is some human trash as well. You see it very clearly how they're being transferred from one side to the other. They most likely being transported across the seabed, and then they hit the. You see it here very obvious. They hit the pipeline from the side, and they either get trapped or they just keep going. But here you see it how they're being heavily moved and transported. Our organism coming up. What is it? Looked like an octopus. Oh no, it's another Solaster, another starfish with trapped carcasses under it, feeding on them, most likely engulfing them. They have enough food in here. Some of the actinostole again on the seabed, on the soft sediments. Not many carcasses anymore here. Again, patchiness everywhere. Shallow, deep, and now again, density coming up. A lot of patchiness. Carcasses being transported again, moved down to deeper depths where they would finally decompose and lock away all the carbon. We're still 2 minutes to finish this survey and this video, so we're gonna just run to the end with live comment and then we just close it. And you always have the summary video in case you want to, the short presentation video in case you want to check some features. This is a long video, but well, it gives a clear idea of jelly carbon benthic processes along shelves and slopes. We think it's one of the best, if not the best, evidence we have for a mass deposition event of jelly carbon in the world. There's very good work from colleagues with cameras and also videos and traps, but what is from video and ROV and in terms of deposition, this is amazing. There you have another fish, just picking on some of the Actinocephia, which you see in front of us. They're closed. We cannot really say if they just found something or they don't like the current that strong or the particles and they're just closed, but normally they're open feeding. ROB just stop here. So yeah, this is coming to a close. We still have 1 minute to go. So just to sum up, we'll just like to say that we hope you enjoy the videos, the live audio and comments and all the inputs I'm spontaneously adding here, and well, that you read the paper and that if it's your topic, you make good use of it. And yeah, and for those researchers that don't really work on this and they don't really believe that jelly carbon is important, we hope we can persuade them about the importance of jelly carbon in the oceans, and they can't really see how big it's a deposition and that all the organisms are feeding on it. So, yep, we just want to thank everybody. Thank you.